Good morning students. Welcome to 11th standard chemistry video class. In this video, we are to start with the new lesson. Lesson 12, Basic Concepts of Organic Reactions. In this lesson, we are to discuss the following topics. Introduction, fundamental concepts in organic reaction mechanism, fission of covalent bond, hybridization of carbon in carbocation, nucleophile and electrophile, and electron displacement effects in covalent bond. First, we will start with the introduction. Introduction. What are chemical reactions? A chemical reaction can be taken as a process by which some existing bonds in the reacting molecules are broken and new bonds are formed. Or otherwise, in a chemical reaction, a reactant is converted into product. This conversion takes place in one step or more than one steps. A general organic reaction is represented here. Substrate plus reagent, which forms intermediate state or transition state, and this intermediate state or transition state forms the product. Here the substrate is an organic molecule which undergoes chemical change. Next one, the reagent. It may be organic, inorganic, or any other agents like heat, photon, etc. that brings about the chemical change. Many chemical reactions takes place in one or more than one steps. Here, the reactants does not forms the product directly. The reactants first forms the intermediate state or transition state, and this intermediate state or transition state forms the product. This series of simple steps which collectively represent the chemical change from substrate to product is called as the mechanism of the reaction. The slowest step in the mechanism determines the overall rate of the reaction. Next topic, fundamental concepts in organic reaction mechanism. Here, the conversion of reactant into product is said to be chemical reaction. The steps involved in conversion of reactant into product is said to be reaction mechanism. It may take place in single step or multi-step. The mechanism is the theoretical pathway which describes the changes occurring in each step during the course of the chemical change. In an organic reaction, we have to note the 2 points: direction of flow of electrons and type of intermediate formed during the course of the reaction. Here, the direction of flow of electron is represented by curved arrow. The movement of pair of electron is represented by a double-headed arrow, which starts from the negative side and ends with the atom to which the electrons need to be transferred. Next topic, fission of a covalent bond. All organic molecules are organic compounds made of covalent bonds, where the covalent bonds are formed by the mutual sharing of electrons between atoms. Hence, each bond contains 2 electrons. Here, the covalent bonds break into 2 different ways, namely homolytic cleavage and heterolytic cleavage. Homolytic cleavage means splitting of electrons in the covalent bond equally or symmetrically. That is, symmetrical splitting takes place. Heterolytic cleavage means splitting of electrons in the covalent bond unequally or unsymmetrically. That is, unsymmetrical splitting takes place. The cleavage of a bond in the substance is influenced by the nature of the reagent or attacking agent. Here we are having two types of cleavages, namely homolytic cleavage and heterolytic cleavage. First, we will discuss homolytic cleavage. Here, the covalent bond is formed between two atoms in a molecule. Each covalent bond contains two electrons. The covalent bond breaks symmetrically in such a way that each of the bonded atoms retains one electron. That is, atoms in a molecule take each electron. This type of breaking is said to be homolytic cleavage. It is denoted by a half-headed arrow or fishhook arrow. This type of cleavage occurs under high temperature or in the presence of UV light in a compound containing nonpolar covalent bond formed between atoms of similar electronegativity. Here, the atoms in a molecule contains similar electronegativity, then it undergoes homolytic cleavage. Hence, this type of cleavage of bond results into free radicals. They are short-lived and they are highly reactive. Hence, this type of reagents that promotes the homolytic cleavage in substrates are called as free radical initiators. Hence, they forms free radical when they undergoes homolytic fission. Again I repeat, if the molecules undergoes homolytic fission, it forms free radical. For example, azo bis isobutyronitrile and peroxides such as benzoyl peroxide are used as free radical initiators in the polymerization reaction. Here, the free radical with an unpaired electron. Hence, this free radical is neutral and unstable. In order to attain stability, it has the tendency to gain electron. Organic reactions involve homolytic fission of carbon single bond carbon forms alkyl free radical. The stability of alkyl free radicals is in the following order. Here we are having carbon single bond carbon. The single bond is covalent bond. It is formed by sharing of electron between two atoms. Each carbon atom shares one electron and forms a covalent bond. Hence we get C single bond C. When this compound undergoes homolytic fission, each carbon atom takes its one electron and forms the free radical. It is given by C dot. The dot represents free radical. Next topic, heterolytic cleavage. Here, the covalent bond is formed between two atoms in a molecule. Each covalent bond contains two electrons. The covalent bond breaks unsymmetrically or unequally such that one of the bonded atoms retains the bond pair of electrons, or one of the bonded atoms takes the bond pair of electrons towards itself. Of the two bonded atoms, the most electronegative atom takes the bond pair electron, that is 2 electrons, and become the anion, and other atom becomes the cation. The cleavage is denoted by a curved arrow pointing towards the more electronegative atom. For example, in tertiary butyl bromide, the carbon bond bromine is polar. Here, bromine is more electronegative than carbon. Hence, bromine attracts the bonding electrons from carbon bond bromine. Hence, carbon bond bromine undergoes heterolytic cleavage to form a tertiary butyl cation during hydrolysis. Therefore, tertiary butyl forms cation and bromine forms anion. It is given by Br minus, that is bromide ion. It is shown here. Next, let us consider the cleavage in a carbon bond hydrogen of aldehydes or ketones. Here, carbon is more electronegative than hydrogen, and hence the heterolytic cleavage of carbon bond hydrogen results in the formation of carbanion. Carbanion means carbon with a negative charge. This reaction is aldol condensation reaction. Here, OH minus ion takes alpha hydrogen from the aldehyde, which leads to the formation of the carbanion, which is shown here. What is alpha hydrogen? Here, CH3CHO is acetaldehyde. In this CH3CHO, the functional group is aldehyde, that is CHO. The carbon next to aldehyde group is called alpha carbon. The hydrogen present in the alpha carbon is said to be alpha hydrogen. Hence, OH minus takes alpha hydrogen and forms carbanion. This is due to heterolytic cleavage. In our last example, we discussed the formation of carbocation. In this example, we discuss the formation of carbanion. The formation of carbocation and carbanion is due to heterolytic cleavage. Next topic, hybridization of carbon in carbocation. Here, carbocation means carbon with positive charge. In a carbocation, the carbon bearing positive charge is sp2 hybridized. Again I repeat, in a carbocation, the carbon bearing positive charge is sp2 hybridized. Hence, it has planar structure. In the reaction involving such a carbocation, the attack of negatively charged species, that is nucleophile, take place on either side of the carbocation. Here, carbocation with the positive charge, it is attacked by negatively charged species, namely nucleophile. It is shown here. This picture explains the shape of carbocation. Next one, carbanion. The carbon with the negative charge is said to be carbanion. The carbanion are generally pyramidal in shape, and the lone pair occupies one of the sp3 hybridized orbitals. An alkyl free radical may be either pyramidal or planar. It is shown in the picture. This picture shows the shape of carbanion. Finally, this picture explains the shape of carbon radical. Hence, we completed the shape of carbocation, carbanion and carbon radical. Here, we are having the relative stability of the alkyl carbocation and carbanion. Finally, the energy required to bring about homolytic splitting is greater than that of heterolytic splitting. Again I repeat, the energy required to bring about homolytic splitting is greater than that of heterolytic splitting. Next topic, nucleophiles and elctrophiles. First, we will discuss nucleophile. Nucleophiles are reagents that has high affinity for electropositive centers. Nucleophiles are electron-rich substance, hence it attacks towards the electron-deficient site. Nucleophile contains an unshared pair of electrons. In order to share its electrons to form a covalent bond, it needs a electropositive center and gets stabilized. The nucleophiles are negatively charged ions or otherwise electron-rich neutral molecules, since they contains one or more lone pair of electrons. All Lewis bases acts as nucleophile. What is Lewis base? The substance having the tendency to donate a pair of electrons are called Lewis base. This tabular column explains the types and examples for nucleophile. Here we are having two types of nucleophile, namely neutral nucleophile and negatively charged nucleophile. Consider neutral molecules having unshared pair of electron. The following are examples for neutral nucleophile. Ammonia with the formula NH3 and amine with the formula RNH2. Here the electron-rich site is nitrogen with one lone pair of electron. Next, water with the formula H2O, alcohol with the formula ROH, ether with the formula ROR. Here the electron-rich site is oxygen with two lone pair of electron. Next, hydrogen sulfide with the formula H2S and thiols with the formula RSH. Here the electron-rich site is sulfur with two lone pair of electron. The following are examples for negatively charged nucleophile. Chloride Cl-, bromide Br- and iodide I-. Here the electron-rich site is X-, where X- represents halide ions. The next one, hydroxide HO-, alkoxide RO-, and carboxylate ion RCOO-. Here the electron-rich site is O-. Next one, cyanide Cn-. Here the electron-rich site is N-. Next, let me discuss electrophiles. Electrophiles are reagents that are attracted towards negative charge or electron-rich center. Here, the electrophile are electron-deficient substance. It is attacked by electron-rich substance. They are either positively charged ions or electron-deficient neutral molecules. All Lewis acids act as electrophiles. What are Lewis acid? The substance having the tendency to accept a pair of electrons is called Lewis acid. Neutral molecules like SnCl4 can also act as an electrophile, as it has vacant d orbitals which can accommodate the electrons from others. This tabular column explains types and examples for electrophile. Here we are having two types of electrophiles, namely neutral electrophile and positively charged electrophile. First, we will discuss neutral electrophile. Carbon dioxide with the formula CO2, dichlorocarbene with the formula CCl2. Here, the electron deficient entity is C. Next one, aluminum chloride with the formula AlCl3, boron trifluoride with the formula BF3, and ferric chloride with the formula FeCl3. Here the electron deficient entity is metal, which is given by M. Next one, positively charged electrophile. Carbocation, it is given by R plus. Here the electron deficient entity is C plus. Next one, proton, it is given by H plus. The electron deficient entity is H plus. Next one, alkyl halides, it is given by Rx. Here the electron deficient entity is X plus. Next one, nitrosonium ion, it is given by NO plus. Here the electron deficient entity is O plus. Finally, nitronium ion, it is given by N plus O2. The electron deficient entity is N plus. Hence, we completed the topic nucleophiles and elctrophiles. Let me stop up to this topic. The remaining that we will discuss in our next video class. Thank you.